right, day 6. Let's wrap up this unit. Unit 9, chemical reactions. Day 6, double replacement and combustion reactions. Yes, blowing stuff up. So let's talk about double replacement first. We've already covered single replacement. Double replacement, double means two compounds react to form two new compounds. So we have compound plus a compound yields a compound plus a compound, but they're new. Why are they new? Because both reactants, compounds, are replacing each other. Notice how the A bonded with the other compound D, and we get AD, and then we have B bonding with the other compound C, and we get CB. So make sure you know this alphabetical version of a double replacement and actually all the chemical reactions.
Report to the business office.
Because probably going to be questions on the test that are just like this, where we need to give you this form and we're going to say it's a double replacement reaction. Anyway, let's look at an example of it. We have copper 1 sulfate plus beryllium oxalate. All right. So if copper 1 and sulfate are dance partners, plus beryllium and its dance partner oxalate, they're going to switch dance partners. They're going to do do-si-do and switch partners to give you a double replacement reaction of copper 1 oxalate plus beryllium sulfate. Notice how I didn't even mention an activity series of metals or how reactive metals are. If you're in a double replacement, it doesn't matter how reactive your metal is compared to the other metal, or your non-metal, how reactive it is to the other non-metal. You will switch partners. So you do not need to use your activity series sheet for a double replacement reaction. All right. So just like everything in chemistry, there is an exception, and this isn't really an exception, it's just an example of a double replacement, and we call it a neutralization reaction. Neutralization, we're neutralizing an acid. And how do you neutralize an acid? You add a base. You add something that's more basic, which will increase the acid, meaning make it less acidic. So an acid has H plus ions. Bases have OH ions. H plus is an ion because it's a charge. OH minus, hydroxide, look on your polyatomic ion sheet, is a base. An example of a base would be a metal hydroxide, so sodium hydroxide. Here's an example of it. We have aluminum hydroxide or reacts with nitric acid. So nitric acid, what is that? We didn't teach you how to name acids, so we will, of course, give you this form. Hydrogen nitrate. Remember I told you an acid is H plus ions, hydrogen bonded with the polyatomic ion. So you have H plus nitrate. They do a do-si-do. They switch dance partners. They go through a double replacement reaction, and you will get aluminum nitrate plus water. Water will always be produced when you are neutralizing an acid. So you have OH will bond with H, and guess what? That's H2O. Now, combustion, blowing stuff up. Combustion is a reaction with oxygen, and that makes sense, right? Because what does a fire need to stay alive, to increase heat, to make the explosion bigger? It needs oxygen. So you have to burn something, and you have to add oxygen to have a combustion reaction. So what's that something? Well, if you burn carbon, meaning you have carbon as a reactant, you will always produce CO2. If you have hydrogen as a reactant, you will always produce H2O. If you have sulfur as a reactant, you will always produce SO2. And if you have nitrogen as a reactant, you will produce N2. For instance, if you have nitrogen reacts with oxygen gas, you will produce N2. Now, let's look at an example. We have CH4 plus O2. So methane, you don't have to know that name, plus oxygen gas, O2. I have carbon and I have hydrogen reacting with O2. O2, hey, look at that. Ding, 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 ding. This is going to be a combustion reaction. You need oxygen to fuel a fire. So carbon and hydrogen is what's being burned. So if you burn carbon, or if you have carbon reacting with oxygen, you get CO2. And if you burn hydrogen, hydrogen reacting with O2, you get CO2 plus H2O.
Derek St. John, report to the cafeteria.
So we're not done yet. You have to balance this equation. So let's tally it up. And by now, you should be very familiar with balancing. You should feel comfortable with balancing equations because we've been doing it since day 2 in Unit 9. How many carbons do I have on the reactant side? 1. How many hydrogens? 4. How many oxygens? 2. How many carbons on the product side? 1. How many hydrogens? 2. How many oxygens? 3. So now let's balance it. Let's add a 2 in front of water, and we get H2O. 2 H2Os, that is, which changes my hydrogens to a 4, but changes my oxygens. So now I have 2 oxygens plus 2 oxygens gives me a total of 4 oxygens. Since this is an even number and 2 is an even number, it's pretty simple to balance this out. We get a 2 coefficient in front of oxygen gas, O2, and that changes it to 4. This is balanced. Now, a helpful tip for balancing combustion reactions is to balance the O2 last. And that's exactly what we did here. But this was a simple balance at the end when we balanced everything else first because it was an even. What happens when it's odd? Balance the oxygen last. You'll be thanking me, okay? If not, it'll be a lot more work, and you can still balance it a different way, but it'll be a lot more tally marking and crossing out and adding up. Okay, here's another example. Ignore the yellow X's for now because Mrs. Flint and Mr. Miller cannot use PowerPoint correctly. So we have H3N plus O2, so ammonia plus O2. This is combustion. So what is produced when you burn hydrogen? That's water, and also nitrogen, you get N2. So there's our products. Let's balance it. Hydrogen, nitrogen, oxygen. Let's go ahead and tally up both sides. On the left side, the reactant side, I have 3 hydrogens, 1 nitrogen, and 2 oxygens. On the product side, we have 2 hydrogens, 2 nitrogens, and 1 oxygen. Remember, balance oxygen last. So let's just balance our hydrogens. Since there's a 3 and a 2 here, the lowest common denominator between odd and even is 6. So 3 times 2, if I put a coefficient here in front of water, gives me 6 hydrogens, but that changed oxygen, so let's go ahead and update that. We get 3 oxygens now. Let's balance out our nitrogens. If I put a 2 in front of here, I now have 2 nitrogens, but it also balances out my hydrogens because 2 times 3 is 6. Let's go ahead and update our nitrogens. Now, everything else is balanced. We have 2 6s and 2 2s. Hydrogen and nitrogens are now balanced. Let's balance the oxygens. Here's a helpful tip. Put the ideal decimal coefficient, then double all coefficients to balance. What does that mean? Put a decimal number here that when multiplied by 2 gives you your odd number. Okay, so how do we get that number? What's 3 divided by 2? 1.5. 1.5 times 2 gives you 3. Okay, now you can't have 0.5 of an atom, 0.5 of a molecule. This is just simple math of what we're doing, but in nature you can't have that. So how did we change this 1.5 to a whole number? We multiplied by 2. If you multiply this by 2, you have to multiply each coefficient by 2. So when we do that, 2 times 2 is 4. Now the yellow X is coming into place. 1.5 times 2 is 3. 3 times 2 is 6. And 1 times 2, because there is an assumed 1 here, you have 1 and 2. 1 times 2 is 2. Update both sides of your tally system. We now have 12 hydrogens on the reactant side. We now have 12 on the products. We now have 4 nitrogens reactants and 4 on their products. Our oxygens now is 6, and our product side is also 6. So this is balanced, okay? using this decimal will save your life trying to balance these combustions, because we can get to really high numbers, and there's going to be a lot more crossing out if you don't use this decimal here, as in crossing out in the tally system, which means it gets messy. You might make a mental error. You might make a mistake. So please use this decimal system, or this decimal trick, when balancing only combustion reactions, okay? Save oxygens for last, put the correct decimal in, multiply by 2, then multiply them all by 2. Pretty picture. Go ahead and start your worksheet, okay?